Welcome to myprojectbazaar.com.
Now we are going to discuss about the product EEG signal processing for epilepsy and autism spectrum disorder diagnosis. Now we are going to discuss about the abstract for the process. EEG is a widely used tool for the clinical investigation of epileptic seizures, a new scheme of epileptic seizures detections using the statistical features and discrete cosine transform, that is the DCT, is presented in this paper. Hence the standard deviation and the three other feature is taken as the discriminative features between the different classes of EEG under study. The DCT was used for feature reductions and as well as for the feature extraction, whose ability to pack input data into a few coefficients as possible makes it is good choice for the purpose. The representative DCT coefficients were given as an input to the linear classifier to yield the respected accuracy. Hence, this process involved in the steps like the filtering, feature extraction and classification. Hence, the feature extraction and classification provides the more reliable and then the more accuracy. Hence, the feature values are more stable to classify whether the input signal is the normal or abnormal. Now we are going to discuss about the flow diagram for the process. This is the overall flow structure for the process. At first, the input signal is taken from the dataset. The input signal is basically in the EEG signal, that is from the dataset. The dataset is the folder which consists of the several input signals. After getting any one input signal from the dataset, the pre-processing is carried out. In this pre-processing step, the bandpass filter is used to filter the noise presented in the signal. After the applying bandpass filter, the feature extraction is carried out. In this feature extraction step, we are using the correlation as well as for the cross correlation we are using the DCT. Under the DCT, we are using the standard deviation, LLE, band power, Shannon entropy were used to extract the feature values from the signal. After extracting some feature values from the signal, the classification was done. So for using the classification, we done the classifiers like the ANN, that is the artificial neural network, SVM, that is the support vector machine, KNN, that is the K nearest neighbor, and then the LDA, that is the least discriminative analysis. By using these classifiers, we classify whether the input signal is normal or abnormal. For the classification step, we have to give the three things as an input: test feature, train feature and target. The test feature represents the feature of the input signal, and the train feature represents the feature of the whole dataset signal, and the target represented the characteristics of the classification, that is the whether the input is normal or abnormal. In this process, we have the two type of targets. After the classification result will be shown as a message box as an normal or abnormal. After the classification, performance estimation is done by the parameters like accuracy, sensitivity and specificity. By using these three parameters, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2000B and change the current directory. If you want to execute the code, means just right click in the mainfile.m file and select the option run. After running the main file, the dataset folder was open. In that you can see the several EEG signals in the form of DAT file format. Select any one signal from the dataset. The process will be done automatically. It will take some time to display the results. Now the process was completed. I will explain the results one by one. First of all, the figure 1 shows the input signal which I have selected from the dataset. After getting the input signal from the dataset, the input signal is converted into the input signal, random signal, noisy signal, and then the finally smoothed signal. Those results are shown in the figure 2 with the subplots. After getting these results, the filtered signal alone is shown in the figure 3 with the title filtered signal. After the signal filtering, the DCT is applied to the signal to extract the features. Hence the DCT signal, that is the discrete cosine transform signal, is shown in the figure 4. Now the figure 5 shows the DWT signal, that is the discrete wavelet transform signal. After that, the Hilbert transform is shown in the figure 6 with the title Hilbert transform. After the Hilbert transform, the figure 7 shows the test feature results. The test feature results are shown in the tabulation. After that, the classification will be done by using the ANN classifier. The result of the ANN classifier is the normal. After that, the classification is done by using the SVM classifier. Hence, the result of the SVM classifier is normal. And then the classification is done by using the KNN classifier. The result will be shown here. At last, the LDA results are also shown here. Now the accuracy of the process is 94%. Error rate of the process is 6%. Sensitivity is 88%. At last, finally, the specificity of the process is 100%. Now the results are also shown in the command window.